Okay, let's try again. That works. First of all, welcome to the stream. Um, oh, yeah. I don't want to write on my CV that I am inept at my development work because I can't get my knee to go to work. It's embarrassing. Uh, I want to be a developer. Your statement about just wanting things to work is very true. Um, you know, when people talk about software quality and stuff like that, it's often um, code word for something else, right? And you know, um, sometimes when people are talking to you about quality, really all they're asking is that your software just works, right? Um, so yeah, I get it. I want my software to just work too. The other thing though is I want the software that I write to just work, and so that's important also. Um, but anyway, let's finish up the migration that we were doing, right? And I always forget where to put the regexes, right? Um, so I've got just the schematics to upgrade. Okay. Schematics slash Angular. And while that goes on, um, you're using Angular. Let's not overreact now. Dude, shots fired, man. Brother, what's going on? I get it that you're frustrated that your NeoVim doesn't work. You uninstalled the Angular plugin and it felt good. Man, you're on the wrong stream, brother. Oh, that's hilarious. Um, hey, Ole, welcome to the stream. Thanks for joining. Um, I guess as we're getting stuff going this morning, I I'm working on just getting back into my streaming schedule and stuff like that. And I've made some changes recently that are going to lead me in that direction. Um, so like today I'm streaming. Tuesday I'll be streaming at my regular time. Wednesday I'll probably stream at some random point during the day. Um, and then Thursday I'll stream at my regular time. Friday I'll probably stream at some random point, and it'll probably be like that for a little while. Um, there's a bunch of stuff that I just want to explore and take some time to dig into. I figure if I'm going to do that, I may as well put it up on stream, right? Um, so there may be some random streams throughout the week that just pop up as I get some time and I want to explore some stuff. Um, so yeah, I want to be a developer. If you're just going to be uninstalling Angular, they're not going to be interesting to you, brother. Oh, if you're going to troll me today, I'll troll you right back. Um, so let's see. Um, so we just upgraded Angular. We just upgraded NX. Um, let's go see what else there is to upgrade. All right. So we have a couple of things to upgrade. Last week we spent quite a bit of time working on ESLint. We got our ESLint stuff to work. Oh, Faker upgraded. NGMox updated. Storybook, stylistic. We should probably upgrade that one. Testing library also updated. And then TypeScript ESLint utils updated. We just upgraded to Angular 19.1.1. So if we look at this, so we went from 19 to 19.1. One thing we can do is we can go take a look and just make sure TypeScript. Yeah, that's Faker. That is Faker.js. It's one of my favorite tools to use with testing, because I can specify the shape of what I want, and so I'm not generating truly random data like random characters and stuff. Like if I want a person's name, Faker will give me a person's name, right? It won't give me the same name every time, but there are other things you can do in your CI/CD pipelines and in your runs to where you can get Faker to give you a seed, and then when you run your tests, you can feed Faker that seed, and that way, right, you get tests that could potentially fail in your CI/CD pipeline, which is close to property-based testing. And we did property-based testing a little while ago. I'd like to get back into property-based testing with Angular, and do a little bit more exploration on that. But basically with property-based testing, what you do is you set up a tool that's designed to try and break certain properties, right? Property-based testing is very black box, where you test the outside interface of whatever you're testing, but you throw stuff at it, right? So say you're testing a function that takes a number. Maybe you throw a string at it. Maybe you throw undefined at it. Maybe you throw -1 at it, right? Maybe you throw negative max integer at it, right? Maybe you throw max integer at it. And what happens with property-based testing is that it hits your tests with all sorts of stuff and tries to break it. If it finds a case that breaks it, then with property-based testing, you write your generators in such a way that the generator can try to generate the simplest case that fails, right? So like the default sort in JavaScript, and this bit me recently in something that I put together, because I always forget this, right? But the default sort in Angular, or not Angular, in JavaScript is string based. So if you have like an array of integers and you call .sort, it's going to be a string based sort, which is interesting because it's not the sort that you would expect, right? So like say you want to sort the integers, I don't know, 1, 2, 3, 10, 11, 100, 101, 110, 111, right? You're going to actually wind up with like 1 and then 10 and then 11 and then 100, 101, 110, right? And then you get 2 and 3 at the very end, right? That's not the sorting that you want. However, if you never get, like if you only sort the numbers like 1 through 9, you're never going to encounter that situation. And that's where property-based testing comes in, right? It allows you to generate stuff that may be outside of what you normally would, right, in your testing. One statement that I like to make is that good testers often don't make good programmers, and good programmers often don't make good testers. And the reason is there's a different mindset, right? A really good tester goes into something with the mindset that, hey, I can break this, right? And I'm going to break this. A really good programmer has to go into something with the mindset that, hey, I'm going to make this work, right? Those are two different mindsets. And they need those mindsets to be good at their jobs, right? Like you want your testers breaking things. That's if your testers aren't breaking things, they aren't doing their job, because none of us write perfect code. On the flip side, a developer who goes into and gets too bogged down in every way that something can break is not going to produce good code, right? They'll never complete, because they're like, oh no, this could break this way, this could break this way, right? And you get stuck in the kind of the swamp of perfection, right? And perfection's kind of a trap. Well, I won't even say kind of. Perfection is a trap, right? You're never going to be perfect, and if you always strive for perfect, you're never going to release. Because there's always going to be something that you hate, right? You're always going to be holding your nose about certain parts of your code. It's just you have to do it to be able to release your code. But anyway, getting back to it, right? Faker.js is kind of, in my opinion, like property-based testing light. It's not going to test every input, but what it is going to do is on every testing run give you different inputs to your code. And the benefit to that is you may catch something, right? Like maybe Faker generates a longer name than you've ever tested, or maybe Faker generates a name that's only one piece instead of two, or maybe Faker generates 3 instead of 2, right? Or who knows what, right? Like maybe a first name that has a hyphen in it, or who knows, right? And so eventually it may catch something for you as you run your tests. So yeah, that's kind of my Faker.js thing. Hey, Marcus, good to see you early into the stream. So yeah, that's the reality of software. If you're only writing your own software, be as perfect as you want, explore whatever you want, right? But as soon as you're working with a team, or as soon as you're producing software to be consumed by others, a working implementation is infinitely better than the perfect implementation that's in your head. And what I mean by that, right, is something that only exists in your head. And like I struggle with this. It's something that I have to recognize in myself, and I struggle with it quite often. But I have a very analytical mind, and because of that, it can be difficult for me to start something, right? So a good example of this is like with video games, right? Like open world video games. If I go into one blind, not knowing what the game is about, I'm going to enjoy it and I'll play it and I love it, right? But say I find a game that I really love, and I want to play it again, right? Like Horizon Zero Dawn was amazing. I've wanted to replay that one just to experience the story again and stuff like that. But there's a problem that my brain is so analytical that it's analyzing all the steps I need to take to finish the game. And it becomes very difficult for me to even start, because I'm like, oh, and then I've got to do this, and then I've got to do this, right? It's the same thing with programming. And so I have to stop myself and slow down and be like, no, you don't have to do all that. That's just, your analytical mind. That's why I call it the swamp of perfection, right? Because it drags you down, it slows you down. And if you wade through the swamp, it's going to take you way longer to get to where you want to be than if you take a safer route. So make sure your software works. Make sure your testers break your stuff. Make sure you approach stuff with the idea that you're going to work. And then always make sure that there's something in there that is trying to break your stuff. That's not you, right? And you'll be successful at what you do. Yeah. And we can go into it more in depth also, Augustine. Anyway, let's go take a look at version compatibility. There it is, right there at the top. Oh no, we don't have the table updated for 19.1. Oh no, we do. I just needed to refresh the page. So 19.1 works with TypeScript greater than 5.5, but less than 5.8. So we can do the upgrade to 5.7. That's what I wanted to take a look at. So we can upgrade our TypeScript now. And then after we do that, I want to take a look at the ES. I don't think I need to look at that one. If we break ESLint again today, we'll fix it, right? And again, you know, like I said last week, some of the stuff I do for content, right? Like, and I recognize that. So my recommendation is if you see a major version jump, you go check out what changed. And maybe I should do that just to, right? So we come back here and we take a look at ESLint config dash prettier, right? And we go take a look at where is our release notes? So we'll just take a look at the releases and see if we've got release notes in here. So they migrated to change set for automatically releasing. Oh, they're supporting the stylistic ESLint plugin. Cool. They aren't listing any breaking changes. I wonder if the stylistic change is what made it breaking. We got a chore. Yeah, I'm not sure why this is a breaking change. So we'll go ahead and upgrade that too. But let's get our testing migrated, and then we'll get our linter migrated, and then we'll take a look at everything else. So to migrate our testing, we're gonna use NX for that. And the reason for that is that like ng mocks might have upgrade stuff with it, right? So we'll migrate ng mocks. And then we'll migrate, well, we don't have to migrate Faker, but we'll upgrade Faker. We'll migrate, we don't need to migrate testing library. Faker. Testing library is not Angular specific. Faker is not Angular specific. That's an ESLint plugin, ESLint. That's Storybook, TypeScript, and TypeScript ESLint. Yeah, so I really think that we get that one in. So we've now upgraded ng mocks. And then we'll come back in and we're just going to grab Faker and a couple, like our testing stuff specifically. What do I think about VTest for Angular? I think it's amazing. And really fast. But the only place where I've used VTest successfully is in conjunction with analog. Um, and Brandon has done a lot of work with analog to make VTest work. I think in the future, VTest will be possible. Around Christmas time, Brandon tweeted something that, it would be amazing if we could get access to the CLI through some sort of programmatic interface, because it would allow people to bring tools like VTest and other stuff to the Angular community without having to do a whole bunch of extra stuff. And Miko said, hey, we can look into that, right? Which was pretty awesome to hear. So I hope it comes to Angular. I really like VTest with Angular. I've never done it outside of analog, though. Not sure what it takes to get it going outside of analog. Let's go ahead and grab the rest of our testing libraries here. So we're going to toggle everything off. We're going to grab. Oh, I just upgraded that one. So we're going to grab Faker. We're going to grab testing library. I believe that's everything. Oh, I should check that video out. I'll have to check that out, Ole. I would love to. That could be something we could do this week. Is grab a library, get a branch, and take a look at using VTest on existing Angular tests and see what it would take to go from a project that has tests to VTest, and see. Oh yeah, I do have link protection on. If you want to send me just a DM, I'm happy to share it, and you can send that on Twitter, LinkedIn, if it doesn't allow you to do it. But I do have some link protection going on. There's just I wish I could open stuff up. I just have to be very careful. I have to be very careful with what I allow people to do. And by and large, the community is amazing. I haven't had problems. But all it takes is one time, and suddenly, I've got a mess, and I want to avoid that. So let's make sure that everything works after this upgrade, and then we'll upgrade our styles and stuff. So pnpm exec nx, and we're going to do a run many, and we are going to run our tests. Oh, let's see. Let me see if I can give you temporary. Um, um, let's do. I'll go ahead and after the stream um, send a link in a comment. Okay. Let me go take a look at the video. So my content, my live content. Here we go. So it's just really it's just me fishing for engagement, man. That's all it is. Um Comments. There we go. I don't see the comment on YouTube yet. But I'll make sure. Oh, and Twitter. Okay, okay. Perfect. Let's go take a look at Twitter. Oh, Marma code. Sweet. Here's the other thing. Let's go ahead and follow you. There we go. You should be able to send me DMs on Twitter now. That's really lame that you can't message me. Very lame. All right. Anyway, our tests ran. Yeah, I'm happy to follow people. Especially like people in the community who are providing, useful information. So yeah. Thank you for the link. I will investigate it after the stream. But Marma code, I think, is Yunt's. I believe that's his stuff. If it is, it's going to be amazing. So thank you for sharing. All right. So our tests work. We're good there. So let's make sure that we get the rest of our stuff upgraded. I really like npm check update. Like NCU is probably one of my absolute favorite tools of all time. It makes all of this work so much easier. So we're going to grab anything to do with ESLint. So we'll take a look at ESLint plugin, that. We'll grab StyleLint. We'll grab this ESLint. We'll grab TypeScript ESLint. And then we'll grab the prettier config. So again, we're going to run with the -i-u. We're going to toggle everything off. Let's grab the types. We'll grab StyleLint. We'll grab stylistic. Grab that. We'll grab that. We'll grab that one. I want to do TypeScript by itself. And this is one of the things that I really love about NCU is that I can go through and I can pick stuff and then just hit enter, and it runs all the commands for me. If I were to add the --doctor command to my if I add --doctor to my NCU, it goes into this really cool mode where I provide it with the stuff I want to upgrade. And then it runs all my tests. If my tests pass, then it's done. If my tests don't pass, then it does a bisect. And it looks, I don't know if it does a bisect or if it does test by test, or update by update. But it starts removing updates, and then it will run my tests. And then it will remove updates and run my tests, and remove updates and run my test. And then it will find the update that breaks my tests, which is really cool and something that I haven't experimented with yet, but I want to take a look at. So we just upgraded all of our types, our linter stuff. So let's go ahead and lint and just make sure everything works after linting. Oh, I need to upgrade the legacy cache. I can show you guys how to get rid of this message too. Oh. So I have a when I was younger, I played a lot of street hockey with my friends, and I have a bone spur and a calcified tendon, and the problem with like skates back in the day, like inline skates, right? We called them rollerblades, but I think rollerblade is a brand. The problem with them is that they don't have good padding. They're very similar to hockey skates, and so I have a calcified tendon and a bone spur, and every once in a while it just aggravates. It aggravates my Achilles, and today I have painful Achilles. So I may wince as I move that foot around and shift. That's what's going on. Anyways, our linting worked perfectly, so we're good there. So let's go ahead and stage this and just say, hey, we upgraded our linters. We'll go ahead and commit this, and we'll push it. And so that basically just leaves us with a bunch of other stuff to upgrade. I don't want to do Cypress right now. And I don't want to do Storybook either. So in that case, all that's left to do is TypeScript. So we'll go with an interactive upgrade again. And at this point, all I want to do is TypeScript. And this is something that I recommend, you know, if you're going to upgrade something core, like if you're using NX, if you're upgrading NX, if you're upgrading Angular, if you're upgrading TypeScript, right? Something core to your project, do it by itself. And there are a bunch of reasons for that, but one of the biggest is you can isolate it down to itself. And, you know, if you've got good tests and things in place, you can find issues with it before if it becomes a problem, even if it becomes a problem later down the road, you can look at rolling back that one commit, right? Reversing it somehow, however you choose to do it in your CI/CD, right? But if it exists as a larger set of commits, it becomes much more difficult, right? So there are just certain core things that I believe you should always do by themselves. But yeah. All right, so TypeScript is upgraded. This is where we're going to run as many of the things that we have, right? We've upgraded something very core. So we're going to run our linter, we're going to run our test. We're also going to run our component test. And we're going to run our build. So the cool thing about NX is if you want to run a bunch of things together, this is the right way to do it. They showed this to us at Monorepo World, that this is the preferred way to run a bunch of things together. And the reason for that is that NX can analyze stuff in the cloud. And it can determine, oh, this, this might be flaky. I may need to run it a few times, but it can analyze and determine where to do things in parallel. Um, so, um, you know, definitely make sure that you're using, lint test, whatever, at the same time. Hey, Jules, good to see you. Thanks for joining this morning on um, a Sunday, right? So I have to be very careful. Some of the people who show up here are friends, right? And people know a lot about me, right? It's interesting how quickly people, once you're a streamer, people figure out, like, who you are and stuff like that. And that's part of what I expected. The difficult part is having friends who show up and not wanting to dox them, right? And so I have to be very careful. But I almost said something. I just have to be careful. But thank you for showing up, Jules. It's good to have you here. So yeah, the difficult part is when I want to be developer shows up, dude. Yeah, that goes without saying, man. If you guys don't know, I want to be a developer has been here since the beginning. And again, I wanted to say some stuff that might dox him, but he's got a personality that I really enjoy, where he doesn't take what I say and he likes to push back, but he does it in a way that's not annoying. So yeah, so definitely appreciate his line of humor and stuff, and if it, I don't know, he's a good friend of the stream, good friend. So yeah, I think I gave him a challenge. I probably did. He's probably going to take it as a challenge, knowing him. But you need to up your game. I want to be a developer. Anyway, all of our stuff ran after our TypeScript upgrade. I didn't expect anything to really be broken because it was a minor. So we're all good there. Let's go ahead and just commit that. So we've now upgraded TypeScript. And we're in a good place. So all of our tests run. All of our linters run, and we fixed our lint last time. What I haven't done in a while, and one thing I should do, and I didn't do this before the stream. Oh, I've got an update to WebStorm. Let's update WebStorm. So while the WebStorm's updating, let's nx run, or we can just serve it, right? So yeah. Every time I look at your stream, it looks like you're in the terminal, but you don't look like a neo-vimmer. You don't even have a split keyboard. This is very confusing. I use split keyboards. What are you talking about, man? On this laptop, I don't have a split keyboard. I'm thinking about it. I've used split keyboards for a long time. So yeah, it is a Kinesis Freestyle, but it's for a Mac. So that's my professional keyboard. When I want to pretend to be a real developer. On my laptop. So my laptop right now, I'm on an for Christmas last year, my family gave me an Alienware M18. and it has the laptop version of the NVIDIA 4080 in it. And like, if you guys don't know, I love to play games, right? And there are a lot of games that I enjoy playing. There's a good friend of mine who works at NX, and we talk about games all the time. He just suggested for me to go get the Outer Wilds and play through that one blind. I gave him the suggestion that he play through Dismantle blind. And you know, we're doing stuff like that all the time. And you know, Jules and I, we talk about gaming too, and just stuff like that. So you know, my M18 was purchased as a gaming computer, you know, and something that I could travel with. It wound up being my streaming computer, but then it also wound up being my AI computer. And so now I'm realizing that I probably need to upgrade to like a desktop computer, because I want the crazy thing. And this is the way it is always with laptops, right? So when you buy a gaming laptop, right, it's going to advertise that, hey, you've got the NVIDIA 4080, but it's not really the NVIDIA 4080. It's the NVIDIA 4080 Laptop Edition. What does that mean? Well, for the Alienware 4080, that means that I've got 4 gigs less of RAM. What does that mean? That means that I can't run like 13 billion models and like 4 by 7 billion models and stuff like that, like a regular 4080 could. I have to do tricks like use gguf files and do offloading to the CPU, which slows down my token per second generation, right? So like on a 13 billion model on this laptop, if I run like like say maybe I run like a 6K model, which is the quantization of the model. So we're getting a little bit off topic here talking about LLMs, right? But so with LLMs, there's this concept of quantization, right? And when you put together an LLM, what you're really putting together are the embeddings. And the embeddings are vectors that represent stuff in the data set, right? Most true models are done at FP16, which is a floating point 16 decimal place precision, right? Even at 8 billion parameters, an FP16 would overwhelm the graphics card I've got in this computer. If I went to like a 4080, I might be able to squeeze one there. A 4090 can squeeze in an 8 billion at 16 floating point precision. And because it's a 24 gig card. What they found is that if you go from an FP16 to an FP8 or 8 floating point precision, you lose very, very little. Right, there's a measure for coherency, and the amount of coherency that you lose when you go from 16 to 8 is very, very small. Probably so small that you wouldn't detect it. Especially in like image generation, you would almost never detect it. In text, it might show up as random misspellings or things like that. Or sometimes the model will get stuck and just generate garbage on its own, right? But those become less and less, you know, they aren't very common. And even if it gets stuck, it's likely that your 16 gets stuck too. Then from there, there's what's called quantization. And what quantization does is it analyzes the tokens and it's like, oh, we can group these tokens together and make them smaller, right? And it allows it allows the model to be shrunk even more. So there are a bunch of different measurements for that quantization, right? So there's like there's 4K, 4M, 4X, 4XS, things like that. And those all represent the fact that you're quantizing some of that 8-bit precision down to 4-bit precision, right? So you're saving half the size of the model. And an important thing to realize when you're running LLMs locally, you need space for the model to fit into your memory, but you also need space for any context that you're using. And if you're using anything like RAG or stuff like that, you're going to need space for that too, right? So you may be able to squeeze like a 12 billion model at like at 5x, right, or 5xs, or who knows, right, into your RAM, which I could do. But as soon as you add, like, say, you add 16K of context, well, that 16K is going to eat up, a couple more gigs of RAM, depending on how it's done. Maybe it's done with sliding windows, who knows, right? But that context is going to eat up more RAM, which is going to push you into using CPU. Once you start using CPU and once you start using local memory, your tokens per second just take a nosedive. So yeah, there you go. You guys got a bit of a deep dive into my knowledge of how to run LLMs locally. That's another thing that I really want to take a look at. To be honest, I run my LLMs less locally. Now I use like featherless AI, um, which I really enjoy. So featherless.ai will give you unlimited hosting for any llama model on Hugging Face, which is really cool because a large portion of models on Hugging Face are llama based. And if you guys don't know, llama is the meta LLM, but they also offer a whole bunch of other models, right? But like this Mistral Nemo Instruct, so Mistral is an interesting it's an interesting idea. Most Mistral models are they're a mixture of they call it MOE, mixture of experts, right? And so they take a bunch of models and a bunch of smaller models, and they put them together, and they found that a bunch of smaller models can perform at or above the level of larger models. It still requires the same amount of memory as a larger model, but it'll perform better. So your Mistrals are typically MOEs. Nemo is a special it's a special instruction set that it's been trained on. And then like this is the meta Llama 3.1 release with the 70B. It's a 70 billion. So this, and the other thing I like about Hugging Face is you can tell the context here, right? So this is a 70 billion parameter model with 16K of context. I couldn't run this on my local machine, but I can spin this up through Featherless and act, through then. I'm not sponsored by Featherless or anything like that, but if you're really interested in running models locally, Featherless has really been amazing for me. And if you take a look at just the sheer number of models that you can get, right? So you've got everything from Llama 2 to Llama 3.3. You've got Mistral, you've got Qwen, which is a cool one, and then RMKV, which I haven't used too much. I think this is a Japanese model, if I remember, but it seems to work really well with English also. Qwen is also a multi-language model, but Qwen Coder has been pretty good. and they offer it in 32 billion and 72 billion parameters, which is cool. Then you've got Mistral, and this is where I'm talking about like your MOEs. When you get into like really big MOEs, you'll see like 8 by 22 billion parameters. This is 8 models at 22 billion parameters that have been put together in the MOE method. So you've got 8 experts working at 22 billion. So this winds up being like close to like, what is that, 176 billion parameter model, but it will often perform better. This is probably, yeah, Wizard LM. Wizard LM is probably one of the most popular. Wizard was a coding model put together by Microsoft using the Mixtral method. So very, very cool. This is probably my favorite place to go for hosting models right now. But anyway. What kind? I'm doing all sorts of stuff. I do a lot of stuff just personally. I've been doing like text analysis. I've been learning how to do my own RAG and embeddings. For a while, I was trying to train a model to do Angular, but didn't find a good model that I liked. For the AI image generation, I still run AI image locally, but for the AI image generation, I've done a lot of stuff for like you guys may have seen that my daughter. I'm super proud of her, but you may have seen that my daughter did. So they just had their regional championship, and drill is a very team-based sport where they go out and they dance and they compete as a team. But at the very end, there's an individual sport called a drill down. Drill is has like military roots, and so marching and stuff like that is a big part of drill. The drill down is really very similar to like a military style drill down, where they have an instructor at the front who's calling, left face, right face, about face. They start calling marching commands and things like that. There were over 200 girls in her region. And Zoe took first place. Yeah, she did really, really well. So very proud of her. Anyway, I got distracted. I'm using image-based models because I help generate like this year their show is about Yzma from Emperor's New Groove. So I'll generate like images that are done in Yzma style of the girls, or I'll put the girls in an image with Yzma, or just stuff like that. So yeah, we were very proud of her. In fact, so they drill down to the top 5. The top 5 received medals. So when she was in the top 5, you guys can probably hear my voice is still recovering. We were just cheering so loud for her on Thursday night. So when she was in the top 5, we were going crazy. It was her and another girl on her team. So 2 out of the 5 were her team. The other girl went out immediately in 5th place. So we're like, oh, she's got 4. She's at least in the top 4. Then a girl from another team went out, and we're like, oh, she's in the top 3. And then they went again, and 2 girls made mistakes at the same time. And I'm just cheering as loud as I can. And my wife is like, what's going on? I was like, she got first. She's like, what? I was like, those 2 girls are going for 2nd and 3rd. And they brought my daughter to the front. And they're like, she got first. These other 2 are going for 2nd and 3rd. And we were just cheering as loud as we could. And it was really exciting. And I was talking to her afterwards, and she's like, Dad, I just went in there. And I was like, I'm going to get first. And she's like, I just focused really, really hard on what was being said. And they do like crazy stuff where they'll be like, They do like this by the numbers thing, and by the numbers means that some commands only have one move that you're supposed to make. Some have two, some have three. And so, they'll call out a list of commands, and you're not supposed to move at all until they say, like one. And then you make that command, you do whatever that one count is, and then they might call two, or they might go one and then four, or one and right, to try and mess you up. And they'll do other things like give you a list of commands, and then they'll say cancel the second and third command, and there's just a whole list of rules that these girls have to remember. And she's like, just in my head, I'm just going through the list of commands that I have to keep going. And one of the things that they did that got like most of the people out there is that they went by the numbers, but they hadn't canceled a previous command. And so as soon as they stopped by the numbers, they had to finish that command. And she's like, I just had that in the back of my head. I was so focused. And so it was just a lot of fun talking to her about that. Yeah, Jules, that is actually a really good way to do it. Say it. It's like Simon Says, but you've got 10 judges around there watching everybody, and things down to like if your shoes aren't tied, you're taken out. If your heels aren't together properly, you're taken out. If you flinch at all, you're taken. Like it's crazy just how serious this game of Simon Says is, as you put it, and that's a good way to put it. But yeah, it was a lot of fun, and so they're headed to quarterfinals next. And their team is very hyped about it. If you guys don't, if you like, drill is probably something that most people don't know anything about. It's probably something that I wouldn't know anything about if I didn't grow up in a house full of girls, right? Like I'm the only guy in my entire household. Right. I've got my wife, I've got two daughters, and both of our dogs are all female, right? I have my man cave, and that is the one place in the house where I am safe, and that's controlled by me. Everything else in the house is it's very, very female. We'll put it that way, right? Um, you know, pillows have to be a certain way and things like that, and it's an interesting insight to the female psyche. But yeah, so I know a lot about gymnastics. You guys could ask me about gymnastics. I actually understand how they're judged now, right? And dance competitions and drill team competitions and things like that. But anyway, the in the state of Utah, there are two teams that are just really, really good. And Farmington and Bingham are the two teams that are just amazing. And if you guys are ever curious about, like what drill competition is about, Farmington and Bingham have a ton of stuff up on like YouTube. This year, Farmington's show dance it's amazing. Like when I saw it, the very first competition that Zoe's team was in, they went up against Farmington. And after seeing Farmington, I just kind of looked at my wife. I was like, yeah, we can go home. We know who won. Farmington was amazing. This year, Bingham's not as strong, which is interesting. The good news is that the school that my daughter goes to, they're better than their rivals. So at least they don't have to deal with their rivals, right? So, and for everybody not in the U.S., high school sports are an interesting microcosm of like all sorts of crazy stuff. A lot of good stuff happens there. A lot of bad stuff happens there. But in the U.S., people take their sports very seriously. So like, crosstown rivals are a big thing, and so the fact that this year they're better than their rivals is is a big deal to my daughter. Anyway, I've been distracted for a long time. Let's go serve this up. Actually, I've got it right here. All right, so let's just let's create a puzzle, right? So let's put a 1 here. We'll put a 2 here. We'll put a 3 here. We'll put a 4 here. We'll put a 5 here. 6 here. 7 here. An 8 here. And a 9 here. And this is not enough to guarantee a unique solution. I think it requires a minimum of 12 or 13. I can't remember what it is. But what I want to do is just make sure that as we're going through, so I'm hitting the arrow keys and we're properly skipping over things. So that's good. Like here, it shouldn't continue on and it's not. Here, it shouldn't continue on and it's not. So our arrow keys are working. And let me bring up, let me bring this up and put it to the side. So we can see the events that are coming up, right? And we can see the arrow keys. Everything seems to be working. If I put a 1 in here, we're getting the error highlights, which we expect. If I put a 2 here, we're getting the error highlights, which we expect. So our error highlights are working. So the last thing to take a look at is just, can we solve this puzzle, right? So we're going to use our solver. And one thing oh, you know what? Our pencil marks completely disappeared. When did those disappear? So if I go 1, then a 2, then a 3, and let's put a 4 here, 5, 6, 7, 8, and 9. Oops. And let's create puzzle mode. So we're good here. So did you guys see when the pencil marks disappeared? That was weird. Let me solve a cell. So we've got that one solved. I was going to say that I want to put together a visualizer, but I was curious when those pencil marks disappeared. One thing to notice is we're using wave function collapse. I actually thought that I was clever when I was putting together the wave function collapse. And then after I did it, I went and watched videos, and guess what? Everybody puts together wave function collapse for solving Sudoku. It happens to teach the algorithm very well, happens to teach the concepts very well, and it happens to be a good way to solve Sudoku puzzles. I saw an Angular workshop offering Angular courses. It was written in Vue.js. Oh, that's rough. Oh, that's hilarious, actually. So if you guys don't know, the way wave function collapse works is there's this concept of entropy. And I look at wave function collapse kind of, I'm a big fan of PBS spacetime, and PBS spacetime talks about, like Heisenberg a lot, and, Einsteinian and Newtonian physics a lot. And it's a great place to go learn just about how our current understanding of the universe works. but it also teaches a lot about even just things like the Heisenberg uncertainty principle, and things like that. Um, which, by the way, I'm getting distracted again. But did you guys see that there's a new paper that purports to change the way we understand Heisenberg's uncertainty principle? And that paper has implications for quantum computing. That's something that I'm going to be digging into this week in my personal time, because I'm curious about it. But one piece of the Heisenberg uncertainty principle is until you observe something, right, you can know its speed or you can know its position, but you can't know both, right? And that's the uncertainty principle, right? Well, actually, the uncertainty means that you can't know either until you measure one, right? And that leads to interesting concepts like Schrodinger's cat and stuff like that, right? Which is a whole other topic that I don't want to get off. But the point of wave function collapse is I look at it very similar to the way we understand the uncertainty principle, right? What we're looking at here with this square is we don't know what this square is, but it can be a 4, 5, or a 9. Until we make a decision as to what it is, we don't know, right? Until we observe it, until we measure it, we don't know, right? And some of these have higher uncertainty than others, right? Like this one has a higher uncertainty of 8, right? And this is kind of what I mean by when I say entropy, right? Wave function collapse looks at entropy. And if I were to make a guess on this one, I have a 1 in 8 chance of getting it right, which means I have a 7 in 8 chance of this being wrong. That's a high likelihood that I'm going to get it wrong, right? High entropy, very unlikely that I will get what this needs to be correct. However, if we contrast it with this square, right, that has 3 possible choices, well, I've got a 1 in 3, right? It's almost 3 times more likely that I get this one right than this one. And that's the way wave function collapse works, is it analyzes the entire space and it says, oh, in this I've only got a few choices, let's make a choice, right? And this happens to work really, really well for Sudoku. It happens to work really, really well for tile generation. I watched a video last week of, and she was amazing. She used wave function collapse to build 3D castles. And watching her strategy for doing that was incredible. But the cool thing about wave function collapse is we can look at these similar to wave functions in physics, where if we collapse this down to one value, say I pick a 4 here, right? It's going to collapse every 4 in this column, every 4 in this region, and every 4 here. So by picking this, we actually remove a bunch of entropy, right? And so my guess is it's going to pick that one. Yeah, and it picked a 5, right? By picking a 5, we've got this one that has 3, and these ones have 4, and everything else has a higher entropy, so it's going to solve this one, right? And so if we solve that, now we've got 3 cells, right? The next thing it's going to do is it's going to look at these 3 cells, but it can't pick a specific cell, so it's going to pick a random one and pick a value, right? And then it's going to do the same. And this has to be a 7, the lowest entropy there is, so it's going to pick that. And that's the way wave function collapse works. And so now it's going to analyze and look. I mean, there's a bunch with 4 in the grid. So it picked this one, right? And so it's going to pick the ones with the fewest, the least amount of entropy, because it's least likely that it will get it wrong. based on the state of the table, right? Um, there there isn't a single solution, so it's probably going to be able to solve this entire grid because there's likely more than one solution to this puzzle. The cool thing about wave function collapse is we can go through and we can generate a puzzle solution. And it can do this really, really quickly, right? We're going slow because it's waiting for me to click the button each time. But it could generate an entire puzzle in milliseconds, which is way faster than a lot of other algorithms for doing this, right? And at this point, we're down to the solution, right? We know there has to be a 9 here, there has to be a 1 here, a 9 here, and a 7 and a 5. So it's solved the puzzle. So that all works. And congratulations, you won. So let's reset our grid and let's go to the problem grid because I want to see if we can get to the point where it has to walk backwards. And it will have to. So it chose improperly here because as soon as it picks one of these 6s, it can't go further. So as soon as I hit solve, it should back up. Ooh. So we've got an issue, right? Invalid values is read only. So we do have an issue there. 7 is also problematic. Yeah, we're never going to get out of this situation because it can't fix this issue. Hey, Michael, good to see you. We need to solve this issue. So we'll solve this issue, and then we'll get back into test writing. But because invalid values is read-only, and this was a big change in NGRX signals 19, where it's protecting us from mutating our stuff. And so I've written code that mutates invalid values. And we can go take a look at this here. Let's dock it to the bottom. So if we go back to our console, it's on line 26. Yeah, so I am definitely mutating the stack here, right? Because I set the command stack, and then I mutate it, and I pass it in. I can't mutate this command stack because it could potentially cause, unexpected things to happen. Let's put this back on the side. And let's go take a look at our code. So WebStorm has updated. And let's go here. And let's go back and let's just look at our console. This was on in our solver feature on line 26. Let's go ahead and find our solver feature. So here's our solver feature, and line 26 is where we were making that mistake, right? So set command stack. Relies on the command stack, right? The undo redo feature. So let's close all but this. And then let's take a look at there's our undo redo feature. So if we look at set command stack, so set command stack is just a patch state. So we're good with that. So really, what we need to do is make it so that we don't mutate this, right? So we can use, I've been using a library to do this because I really like the library. Let's just make sure, yeah, that's fine. But I've been using mutative. So if we go take a look at mutative, do I have it up here? I don't. So let's go ahead and grab mutative. Mutative JS. Mutative is a pretty cool library. It allows you to make changes. Is it this one? The mutability. No, it's just, that's not it. It's just mutative JS. We just want mutative. Here we go. Here it is. So this is mutative. And what mutative allows us to do is quite often when we want to do immutable updates, we wind up writing hand-rolled reducers like this, right? Where we use a bunch of spread operators and stuff like that. With mutative, instead of doing all of this and all of the spread and all of the reducers, we can still write code that looks like a mutation, but because mutative uses proxies and stuff, we can write code that we understand, but it's not going to mutate the object. This create is going to give us a new immutable object, right? And that's what we want. So if we go back to line 26, and we can just say, hey, we can just say const next command, command stack equals, and then we're going to create using mutative. And with this, then we just pass it a draft object. And that's it. And then we can move a lot of stuff in here. So there's our create command. And then we can move this into here. But now, instead of doing this, now we can just say, hey, draft, right? Our draft object. And the draft object is the object that has a proxy on it. And so we've just said, hey, our draft is of type unknown. Oh, I need to pass in. I need to pass in the base type also, right? So if we look at their create, it starts with the state and then it's got the draft object. So we need to pass in the command stack. And then we've got our draft, and then it knows what draft is. So now we can say, hey, you know, on our state, the last index run, on our command stack, we're just going to set the invalid values. And then here, instead of using command stack, we just say, hey, we want to use next command stack. And so that allows us to use immutable mutations, I guess is a funny way to put it. So using immutable mutations, we can change this object in an immutable way. But why would we do this, right? Like, yeah, sure, whatever. You know, we could write aren't hand rolled reducers faster? The other library that I was using before this was Immer. But where is their performance here? So like this hand rolled reducer, right? You might be like, wouldn't this be faster? Actually, it winds up not being faster. And the reason for that is these spread objects are actually ON squared. And so we can take, mutative takes a different approach, which winds up being faster, right? So at low ends, this probably performs at the same amount as mutative, but as you start pushing more and more data through it, mutative really starts to get an edge, right? So, probably it looks like below 15,000 or maybe even below 9,000, we start to get an edge around here, right? Between probably 6,000 and 9,000. So if you're looking at between 6,000 and 9,000 operations, and you find it easier to write this, then it's probably not worth bringing in the library, right? But as you start doing more and more, the library starts to show more and more improvement. And, where it really gets crazy is on array mutations. So array mutations 6 times slower than mutative, it says. But notice that for array mutations, mutative is very close to constant time. I mean, out here to 1500, but then it looks like this looks very much to me like a natural log curve, and this looks like it's starting to become potentially an exponential curve, right? So this could be ON squared, and this could be like n log x or some n log n, right? Something like that. And then, of course, they're comparing themselves to the biggest library out there. So you can see, performance-wise there. Anyway, it's been a library I've been using for years. I love it, and it's going to fix our problem. So now if we go back to our grid and we set up the problem grid, and so now we're in our problem grid, right? And we solve one cell, and it managed to pick perfectly for us, right? Because now we've got 3 cells that only have 2 values. So if we solve that, actually, did you guys see that? It actually went across this way. So let's reset the grid and go back to a problem grid. In this case, there's a 50-50 chance that it's going to pick a problem. If it picks a 3 here, we create a problem, right? Because these become 4 and 2, these become 7 and 6. So there's definitely a problem here if we pick the 3 and the 3. If it picks 8, it continues on, right? So nope, it picked 8, right? So at this point, we're in a problem. So if we try to solve a cell and it needed to pick something, so it picked here, right? It's going to pick the 4, but we've got a problem here, and now it's going to roll back, and it's going to say, hey, it set the invalid values to a 2, right? So the invalid value here is a 2. It can't pick a 2. So it picked the 4, right? The 4 is going to lead to another invalid value, right? And so as soon as I hit solve, it's going to walk all the way back. And it walked all the way back to this cell, and it said 3 is invalid here. And the way it does that is it looks for branches, right? And once it picked an 8 here, now it can solve the puzzle. And we can't get into a bad state down here. So our walk back works, right? And we can look at kind of how it looks. And the interesting thing is, it's picking the lowest entropy. So right now the lowest entropy is at 8. Is that correct? Row 8, column 4. Lowest entropy was a 7, 6, 8, 7. I think what this means, I think I've got this backwards, where the lowest entropy represents how many it can't pick. So here the lowest entropy is an 8, meaning that there's only one thing left, right? With the lowest entropy here, there's 2. And we can see that in the array. So here with the lowest entropy of 6, there are 3 choices, right? With 8, there's only one choice. 7, yeah. Well, with 6, there were 6 choices. But, there. But the entropy is calculating, how many choices are there? We're setting our pencil marks, but as we're walking back, we're setting these invalid values. Wherever we set invalid values, those become pivot points. And so as we're walking backwards, if there's an invalid value, we try to pick at that point. If that point, so here, notice we've got 2 and 4 were our invalid values for this array. So we keep walking backwards. And here we said that 3 is an invalid value for this cell. Am I using group by? I don't remember how it works. Let's go take a look. So here, let's take a look at the entropy stuff, and let's see how entropy is calculated. So it's in our wave function collapse solver. So in our wave function collapse, we're calling this get cells with least entropy. I'm just creating a map. I'm iterating over everything. I probably could do something like a group by. This could probably be improved because this is an O(n) squared, right? We're iterating rows and cells. So we're grabbing whatever values to hide from the cell here. And then, so the invalid values, so we've used up a certain amount. And then the entropy map has used value count. So we've got our entropy map. If it has the used value count, then we set that count into the map. So we're using the entropy map. Okay, so what we're doing is we're creating a map of the entropy of the grid. We're saying that the lowest entropy right now is a -1, which actually winds up being the highest entropy, right? -1 is our highest possible entropy because it's bigger than 9, right? Then we go through every grid, and if it's read-only or a value or it has a value, then we skip it. So we're only looking for empty cells. Then we look at any invalid values on that cell. If it has any invalid values, then we look at the entropy map. If it doesn't have that, we create an entry for that used value count, right? So like if 4 values are invalid for our cell, then we say, hey, this cell has 4 unused values. And then we look at the used value count. So the current value is the used value. So we look at the entropy map and we're like, hey, do we have the current value? If it's in there, where does current value come from? Okay. If it's not there, it's the current value. We get the used value count. We push our cell into that array, and then we set that value. So we use both. Values to hide probably uses the invalid values and the row values. And then if our used value count is greater than our lowest entropy, then our lowest entropy becomes our count. Otherwise, we just leave it alone. So basically, we're just walking up, right? And so in the very beginning, our entropy, everything's going to go into, probably 6, 7, or 8, right? Maybe 9. And so it's going to find the lowest entropy. And then if there's only one cell there, then we use it. Otherwise, interesting. There's definitely some optimizations we could make here. Right, we could probably fix this to not be O(n) squared. The interesting thing is that we could probably by creating this map when the grid is created, we could update the entropy map in real time and not have to recalculate it with every button push. Cell value, that's the hustler grind, men's. Yeah. Oh, I was watching something on the hustler mindset in the US. And I'm not going to say it only exists in the US, but it's much more prevalent in the US. Out of a lot of countries in the world, we're by far and away the highest hustler mindset. And like it's over 1 in 3. I think it's like 36% of people in the US have a side hustle. And I think it might be 25% have more than one, which basically means that 36% of people have a regular job, but then they go on to try and make money other ways on the side, and 25% of people are doing more than one way of trying to make money, right? And there are definitely people in other countries that have side hustles, right? That's not unique to the U.S. But what is unique is just the sheer amount of people. Like it's likely that everybody knows that, yeah, that grind mindset, right? Which is crazy because in the US, we already have the least amount of vacation worldwide. We already work the most hours worldwide. Um, but it's our culture, right? In the US, right, if you don't work, you don't pay for food, you don't pay for your housing, you don't have health care, you don't, right? There's like everything. From the moment you get up till the moment you go to bed, and maybe even while you're dreaming, you're worried about money and stuff like that. It's just part of our culture, right? And I used to joke with a boss that I had that um, in life, if you consider life a game, then money is the score that we keep, right? It was the joke that I used to make with him. Um, because that's really like the way it is with a lot of just people that I know in the US where um, if you're making small talk, so what do you do for a living? Oh yeah. How's that working out for you? How much money do you make? Right? Like stuff like that. And maybe it's not so blatant, right? But your small talk is feeling out the other person, and maybe they're not being honest. Who knows, right? Because the worst place to look, in the U.S. to find out how somebody's living is at their social media accounts because that's where they're going to try and provide the best view of their life. Um, but it's really, really common to just discuss with people what they do for a living, what are their side hustles, oh, this is so expensive. What are we doing about it? Right. So, yeah, it can be very miserable, Jules. I totally agree with you there. Um, like, there are a lot of people in the US who have employment just because they need to provide healthcare for their kids, right? And or their family, right? And maybe their partner's healthcare isn't good enough, but they were able to get a job that provides better healthcare. Um, and so they're working a miserable job that they don't like solely for the purpose of providing healthcare, right? Yeah, it is a miserable grind. And just the constant worry about money and um, it can be oppressive at times. And I don't want to say that other countries don't have this, right? I just don't know about how things are in Europe or, Asia or, Africa or, you know, I don't know how things are outside of the US. So I want to be very, very clear that this is very, very US centric, what I'm saying right now. And you guys, it may resonate with you in other countries too. But the studies that I was looking at show very clearly that um, the US mindset is very, very geared towards money. And it shows up in funny ways outside of the US. So, a lot of Europeans believe that like lawsuits and lawyers are very, very common in the US, which they're way more common than other places, but I wouldn't say that they're very common, right? I don't go suing my neighbor all the time. Um, only I try to keep it to less than once a week, right? I mean, anything more than that seems obsessive. I'm joking. I actually have never sued anybody in my life. And it's I do know people who have. I do know people who have been sued, which is a crazy thing to say because I know that, but whatever. We're off on a tangent. After Friday, you want it? Oh, we need to talk, Jules. Yeah, I know how you feel, Jules. I know how you feel very, very, very well. Um, and it would there's some changes coming that we'll talk about once I'm more comfortable talking about them. And some people out there know what's going on. Um, but right now, I just want to focus on positivity. Let's put it that way. So yeah. Anyway, thanks for the question, Michael. Like, thank you for forcing me to go and look at this. And this is the interesting thing about software, right? Like, sure, I'm like, we can optimize this, but is it a best use of my time, right? And when I'm creating content, the best use of my time is often, what helps my audience most. So when I create content, I'm concerned about, how can I help my audience the most? What's entertaining? That helps my audience, right? Entertaining is often, what I'm looking for. But more than that, like what can help you in your day-to-day job become a better developer? Right? Like what are decisions that go through my head, having the experience that I've got, and why are they important? So, when I analyze this, are there things that I would do differently here? Yes. Are they the best use of my time? Well, if it's entertaining on stream, maybe. If it teaches a good practice, maybe. If I was working in a professional, like on a professional team, probably not, right? Like when we go and we take a look at this, right? When I click this button, it's not unreasonable the amount of time it takes to process, the 81 squares, right? And that's a really big piece of when we talk big O notation, right? As processors get faster and faster, and there's an interesting contingent out there that is saying that Moore's law is over, which is very likely. I actually tend to believe a lot of what they've said. Moore's law is likely over, and Moore's law basically said that computing power doubled every 9 months, right? We aren't there anymore. However, Moore's law has gotten us to a point where 81 ON squared, right, it's not bad, right? And if we optimize this, right, like maybe we make it n log n, or maybe we make it log n, or I really doubt we could get to like a constant time of O of 1, or well, I know we can't get to a constant time, right? But O of n, like 81 squared is not that big when compared to a lot of other things, right? And we've got optimizations built in because this isn't really 81 squared, because we've got a whole bunch of stuff we skip. And it's not even 81 squared. Right? It's only an ON squared because we've got a two-dimensional array. We really only walk through 81 squares. So we could argue that we're O of n, right? If we do a deeper analysis, like my naive analysis of a nested loop was really a bit naive, because we aren't, like, for this to be O of n squared, I would have to iterate over the entire grid for this square, and then this square I would iterate over the entire grid, right? In that case, what would we be? Like 80 squared puts us at 6,400. So 81 squared puts us like 6,500, right? 6.5K. right? And I'm going big, right? I don't know what the actual number is. I'm just, back of the napkin numbers, right? So I want to go bigger to give me worst case scenario, right? It's probably worse than it actually is. 6,500 compares, when we're talking like teraflops or gigaflops on typical processors, right? Like that's barely anything, right? And flops are floating point operations per second, right? There's probably more operations than just one, right? So like if we say everything takes, I don't know, 5 operations, right? Just to be on the high end, we're looking at like 50,000 operations to go through this entire table if it was O of n squared. At that point, the numbers start to work against you, right? So we know we're not O of n squared here. And we are O of n because really we're just walking every cell in this table. It just happens to be a multidimensional array because we're walking row by row. So row 1, row 2, right? If we were to turn this into a single dimensional array and put all of these next to each other, which we do in a lot of cases in our logic, then we wouldn't need a multidimensional array, and it would just be, right, an O of n, right? Which is best case scenario for what we're trying to do. So we do 81 operations every time I click this button. Can we improve that? Absolutely, right? There are ways we can improve this. But this is where like analysis comes down, right? Like where are the hotspots in our program? How often are we hitting this? Right? And like even here where we've got a bad solution, we can tell because we've got 2 choices and 3 potential value, or 2 values and 3 potential cells, 2 values and 3 potential cells. We made a bad choice, right? So as soon as we pick this and then this, oh, that's wrong, right? So we walk back to where we get more than one choice. We say 2 was a bad choice there. We solve it, we pick 8. Oh, 8 was a bad choice there. So we've walked all the way back to whatever was causing that issue, right? And now we've got 3 cells, 3 values. And so we've got a solution, right? Anyway, could we make it faster? Totally. Again, we're in a bad. Nope, we aren't. I was going to say we were in a bad state because I only saw the ones there. I wasn't, right? Like my brain was taking a shortcut and it was cutting these out for me. But once I took the time to look, no, we're in a good place, right? Anyway, could we make it faster? Absolutely. How long will it take me to make it faster? I don't know. Will making it faster make the program better? Well, I don't know, because as soon as I hit this button, things show up immediately from my perspective, right? I'm not feeling the need to put in a loading spinner when I threw that one out there for you, Jules. I'm not feeling the need to put in, some sort of waiting animation or loading spinner, or who knows what, when I click this button. That tells me that we're fast enough, right? And this is the trap. In the beginning where I was talking about kind of the swamp of perfection, right? Where it drags you down and slows you down. If I analyze this algorithm, I could make it faster. I could do better. Is it worth it? Well, the reality is anybody who's using this feature, right, that's getting the lowest entropy, they're clicking this button and it's fast enough that as soon as I click the button, I can click it again. That seems to be fast enough for the use case that we're in. Could we make it better? Yes. Should we make it better? Probably not. There's no gain to be had by the amount of work that it would take to analyze that and then make it better. So that's the that's the swamp of perfection, right? Going back to the beginning of the stream. Um, and I think a lot of engineering teams fall into this swamp too. And it shows up in a bunch of different ways. Sometimes it's about algorithms, and sometimes you're talking big O notation. And right, like you're arguing big O notation over, 10 items, right? The difference between O of n and O of n squared for 10 items is 90, right? 90 items is probably inconsequential in your program. It may not always be, right? But it is likely inconsequential, especially if you compare it to things like network overhead and round trips and things like that, right? Like your hot areas may not be where where you think your hot areas are. And there's an interesting quote, and I can't remember if it's like Knuth or Ritchie or one of the old school developers. I should go look up who said it, but pre-optimization is the root of all evil, right? Sometimes the naive implementation is good enough, and that's one of the interesting things to me about when we talk about like hiring and things like that. Right, we look at candidates and we talk about ON squared versus whatever. And it's important that we understand that they understand that. Most of the time, the code that you're exposed to in coding interviews is not the code you're going to be writing. Most of the time, the code that you are expected to write in a coding interview is probably 10 or 12 times better than the code you're going to encounter as soon as they expose you to their dirty little code base, right? And this is across tons of organizations, right? I've worked for various organizations over the years, and it's almost universally true that that's the case, right? Sometimes, you'll be writing leak code, binary tree searches for an organization that's going to have you doing CSS, right, for most of the first year of your career. I don't know. Do I have a better solution? Probably not, but it makes me laugh, right? We're really good at pretending that we are much better than we are, right? So yeah. Anyway, we solved that issue. I'm happy with that. We're gonna be back Tuesday at 5:30. Wednesday it'll be random. I'm probably thinking I want to do something like CST and IST friendly on Wednesday. So it might be around like 11 a.m. my time. What does that put it like? It puts it like 7 p.m. European time ish, right? Depending on where you are. Thursday I'll be back at 5:30 my time. Friday probably 10:30 to 11 ish. And these are all subject to change based on other things that are going on in my life. But yeah, I think I'm going to stream a bunch this week. I want to explore some other ideas. I want to take a look at like some NX generators. I want to take a look at some Project Crystal stuff that I haven't looked at on stream with you guys yet. But I definitely need to end here. I'm gonna go get my heel X-rayed. And I think I don't know. I think it's probably time for me to go get the surgery that's gonna fix that bone spur. So today I'm gonna go get my heel X-rayed and see what they think, and then we'll move forward from there. But thank you guys, everybody, for being here. Really enjoyed it. A bit more theory today, a little bit less code. But I love talking about this kind of stuff, right? It's this kind of stuff that will set you apart in your career from the average engineer. Let's put it that way, right? Thinking not just about, oh yeah, ON is better than ON squared, or right, being able to break outside of the big O notation and start thinking more about the software as it pertains to your specific area, right? So, you know, like on vehicles, right? You know, going back to my auction days, there are only so many areas where you can have damage reported. Is it really worth it to optimize some of that stuff? Probably not. We could probably make more money making the customer experience better, or analyzing, you know, how can we drive more, like auctions make all their money on fees. How can we drive our customers to participate more in, you know, the various programs offered by the auction, so the auction makes more money on fees? That's probably a better use of my time than, oh, this is ON squared. I think if I make a slight optimization, we can go to ON log n, but really it's going to save microseconds. And the customer will never notice it because they can never click the button fast enough for it to make a difference, right? Those are the kinds of things that are really going to set you apart and move you from you know, being square in the center of the pack to being ahead of the pack, and the one that's often looked at for how do we solve this, you know, the one that's often in leadership positions. So I feel like these kinds of things are very important. But yeah, thank you, Marcus, and thank you everybody for being here. It was good to see you all. Just good to hang out with everybody. We'll be back on Tuesday. You guys have a great rest of your weekend.